Welcome to another video episode on my RaspberryPi2 C, which runs Ubuntu Linux and connected to HDMI for monitor, which is currently inactive because there's no keyboard and mouse attached. Serial cable right here, connected to the RaspberryPi2 board for connection to a Minicom serial terminal. Hidden but certainly present network cable for VNC, virtual network computing, and band cable which leads to this breadboard with some fischertechnik electronics, controlled by bash scripting, C as well as C++. Not at the same time, of course, but being used because I want to see whatever the differences are. And also used Mac with VNC. So yeah, this is Mac and this is VNC on the Raspberry Pi. And here I have terminals open for bash. So what is it about? Well, last time I tried to get things working, and that included the motor. Let's follow the wiring of the motor. That is the plus. This is the signal which activates the motor. Green, gray to, well, someplace. And that someplace is somewhere is the question. Last time I managed to successfully get this working. This one, the green LED here and the red one, as well as sometimes the motor. And that sometimes was because of bash. Not because of C, not because of C++. So, what was the reason? Well, my reasoning was that the library I used in C and C++, wiringPi, was old and not capable of handling the extended GPIO, which is this range of pins. And therefore I connected it right here, and yeah, you can just see it. So right here, and then things should run. So if I run it now, you see the motor runs for 5 seconds. That's exactly what should happen. Now C++ does run as well, so that is very nice. However, it was originally here and I still want it to be there, but it didn't work at all. And my reasoning was, okay, like I said, wiringPi is old, but there are different versions. So let's take a look at that and find out if I can get it to work here. So here we are. Executable C program right here. Executable C++ program right here. C code here. C++ code here. And yes, by details you can see that C and C++ are not exactly the same language. Programming language, of course. Well, this is once again the Minicom terminal. But what is interesting? Well, wiringPi. Because if I look at and take a look here at the serial terminal, or I better leave that alone and go to another window. And let me shift this all up. Alright, go to the library, and then I think this should tell it all. No, it doesn't. 2.46. Well, let's go to the website for a moment. And all this one, but this one. It says wiring update to 236, but this is more important. 246. Well, I do not have this one. I do have this one, by the way, for another project. But look at the version number, 246. Okay, let's go back. 246. This means that it should be covering whole of the GPIO. So, going down, and I actually should put it like this. So, it should cover everything. Which also means that in my original intention was 32 something. So now let's go to the Raspberry thing. I had it on 32. 5 from behind. That is here somewhere. But that didn't work. But according to all information, it should work. The other thing, it starts counting here. wiringPi starts with 1, 2, 3, 4, 5, 6, 7, 8, 9. Really. And that didn't work at all. So, question is, should I keep it like this or not? If I now go to that's a good one. If I now go to bash, will that work? Let me check. I give enter. This works, this works. Oh. Yeah, the yellow wire is out. So that is not working. And once again. Yeah. Working. Working, working, not working. Okay, doesn't matter. So let's go back here and test it. C version. Oh yeah, smooth. And I maybe better do it like this. So again. Yep. Smooth right. C++. Yep. All right. I can't stand that it doesn't work when it's connected here, so I'm going to see why. Alright, by studying the documentation on wiringPi, I find that this particular part can be used, but not totally. So I have decided to let the gray wire, which is towards the propeller, be as is. What I also found is that one wiring is a bit odd, which is the wiring from here to wherever, but pin 11 is pin 0 is GPIO 11 as an input. So I'm going to try that one. And yes, I need a flashlight. I haven't unpowered it yet. So surprises can still be there. Okay, no error, so let's try this with, of course, and it's a little bit weak shining now, but let's run it. And oh, right. What should I actually do when there's something done? Well, that's another question, of course. Reading without something else. So, oops, be careful. If digital read 11 or digital read 0 is 1, right, then printf light the photo transistor, because that is what it is. Right. A bit clumsy, but it's alright. And this one up here. Alright. That should work. The same procedure, of course, here, but then with C out. No, with an if is 1. Let's remove this one. C out. Photo transistor. And that's it. Yeah. Now if it is 0, I should still do something. So let's do that immediately. Else if digital read 0 is 0, C out, no light, and that's it. So let's do this one first. it's C++. Do it. Oh yeah, that's an error in here. Digit. Oops. Digital read. Alright. That's better. No, leave that. Go here. And alright. Shine. Go. No light. Again, maybe the light is too weak, possible. No light. Okay, it doesn't detect anything. So these are rechargeable batteries. So I think I should do that. So I have now charged the batteries in this flashlight. I've also adapted both programs for reading digital read 0. So they are basically the same. Compiled, no problem. And now the question is, will it work anyway? So, with a very bright light now, let's run it. No light. Then this will be no light either, I think. No light. So the question is, why is that? It is on 11 and 11 is input 0. So should it take long? No, because I have mentioned in other experiments that it works instantly. So why doesn't it read then? And the problem is going to bash right here. I have input right here as well, and yeah, I realize that you can't read it quite well, but I have here input direction and it has never read. So bash in this case is not a good choice. Remains the question if I can use it, why don't I? Why doesn't it work? One of the things here is with write, I take half a second delay, but that is after the write. And this is indeed after the read. Should I wait? I don't think so. I can't wait. So, yeah, only option is check again. And I suddenly realize I made a mistake. Not on the pin, but on the device. Because I'm talking about pin 11, which is here, but that is not the phototransistor, it's the switch. So, and that was my mistake earlier on as well. So, the phototransistor has to be wired or activated yet. and probably rewired. But I will test again. Press the switch and run the program. And suddenly the motor doesn't work anymore. A bit odd. And I see that one wire has gone out, so the LED won't even work. But press the switch, do it again. Motor doesn't work, but phototransistor, which is actually button and not phototransistor, does work. So the the input is 1. And why doesn't the propeller suddenly work no more? That's a bit odd. Anyway, I have to, of course, change this. So this is button pressed, and this is, of course, no button. And this one is actually the same. And here, no button. So let's now test it without the button pressed. And then I would very much appreciate if the motor would work, but somehow it suddenly doesn't. Yeah, now it does. Alright, and now with button it works. So, okay. Again, without it on C, motor works. With button. Oh wait, I make a mistake. Yeah. Well, anyway, I changed the text, but I didn't recompile. Anyway, the working is exactly the same, and now it should say button, but okay. Let me recompile, then everything is alright in that perspective. And here as well, so now it gives the good text. Remains the fact that the phototransistor is wired to pin oops, there goes a wire. The photo is wired to 13, which is here. However, pin 13 is GPIO 9, not 27. So now I have to refer here, and more appropriately here, which is pin. So pin 13 is GPIO 27, but that is not supported. Or I am wrong. Let's see. Pin GPIO 27 doesn't occur here. Or substitute 27 for. So that means that if 27 would be alright in this place, 0, 1, 2. That would be nice. So that means that I have to use pin mode 2. As an input. Let's just put that in. Alright, new chance with the phototransistor. If the information is correct and I'm understanding it correct, well, the information will be correct, but if I'm understanding it correct, then this one would work now. Should work. So, light C. Wait. Why don't I get the no light? Will be the same happening here. No, here it says, here it does say phototransistor. Curious. So that works. Now let me, a bit complicated, also press the button. I feel the motor, it says no light. So I have to hold it in a specific way. Motor runs. No button, no light. Okay, then I do it like this. I'm just pressing the button. Button press, no light. Yes, and now I do it the other way. No button and phototransistor. And that's exactly what I want to see. So, other way. C. That should give no button and phototransistor. But it doesn't do a thing. Okay, wait. Let me recompile then. I did do, but you never know. Okay, once again. Yeah, phototransistor, so I had to recompile. But let's prove that this works. Strange that somehow Bash doesn't want to read. But at least things do work. That's what it is about. And that's the end of this experiment. So while Bash gives no result on input, and I can try once again if it wants to cooperate, that is, on let's say input is 11 and 22. Well, 11, that is the button. So if I now press the button, and I'm sorry you can't watch that. It doesn't do a thing. Absolutely nothing. So fortunately C and C++ do respond. I'm happy with that. A little bit of rewiring and recoding, but that was nice. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. leave a comment or suggestion, much appreciated. You can also follow me via Instagram and Twitter. Also appreciated is if you make a donation to show your appreciation of the videos. You can donate via PayPal and Wired. More information on my website and under this video. And you can also become a patron and have your name mentioned on my website and also with my videos. This is to be continued. Have a nice day and bye bye.